What's up, guys? Thanks for coming back to another episode of EV Music. And if you're new around here, make sure to hit that subscribe button or the like button if you like this video. In today's video, we're going to be turning the Maschine into a Game Boy. And the way we're going to do that is take sounds from this bad boy, the Game Boy Advance, and we're going to put them through contact into the Maschine, which is made by Native Instruments. So let's get started. So when it comes to sampling the Game Boy or the Game Boy Advance, you really have two options. One, you could, if you have an actual device, you can use what's called a flash card. Oh, that's upside down. Easy Flash Omega. I've been loving this thing. It runs the games pretty much seamlessly. So you can either use this, run the programs on here to generate the sound with an audio interface and capture it that way, or you can just use an emulator, which is what we're going to be doing today.
Alrighty, so the first thing you're going to want to do is head over to openemu.org. I'm going to be doing this on Mac today. If you're on Windows or Linux, I know there's things like RetroArch, or I think Windows you can get MGBA, which is inside of OpenEMU, but this is how we're going to get the Game Boy on our computer, the Game Boy Advance. So once you download that, you can just go ahead and open it up. And it's going to warn you. So you have to go to the security and privacy and just allow it to open, since it doesn't know where it's from, so it's just warning you. But you can go ahead and open it up once you allow it. And you'll be greeted with this fancy 3D kind of looking thing. Or I guess it's a 2D plane, but in a 3D space, which is kind of cool. So I'm going to uncheck all of these because I don't want any of these, but you can have them if you want. It's pretty cool. All right, so I just want MGBA. That's the Game Boy Advance emulator, some emulator library type thing. Some of them you can't uncheck, just don't worry about it. All right, let's go. So now we can just drag and drop our games right here, and then they'll be run. So let's go ahead and figure out how to make one. So now that we have that set up, we need sort of a audio interface that's going to allow us to sort of put the Game Boy Advance audio into a DAW like this. And you can see I'm recording in it right now. So we want to put it into something like that. What I'm going to be using is Soundflower. I'm not going to use Softonic. You can just go to the GitHub right here, Matt Ingall's Soundflower. And then you can go ahead and download this DMG. And it's pretty much the same installation process as the emulator. You're going to have to allow that package again. And once you do that, you should be able to go to the audio Midi setup. And inside here, you can go ahead and create a multi-output device where you have one of the inputs as Soundflower and one of the outputs as your built-in output. So you can see they even give you the instructions right here. And this is kind of how I'm actually recording this video right now. So Soundflower is amazing. Go ahead and check out these instructions. So now we're actually ready to write the program that we're going to be recording sounds with. So we need to generate the sound on the Game Boy Advance in order to record sounds. So how we're going to do that, there's a website where they have an already created template that we can use to create sounds for the Game Boy. So we're going to go ahead and go to this. If you followed my previous videos, you'll know what this website is. So go ahead, download that Tonc code.zip. And once you go inside of here, you'll see there's a ext and then SND1 demo. That's what we're going to be using. So we can go ahead and open this one up here. And we're just going to go ahead and go line by line and write a little bit of code. Should be fun. So this is a blank file. This is nothing, right? This is just going to be the basic sound that you need. So I'm going to go ahead and go to where I've backed this up. Should be on my desktop. So I'm going to go ahead, go to the backup, and just kind of see what I added here and kind of explain it to you guys. So here we have a couple of variables at the top just to keep track of some stuff. So first of all, we need to keep track of what note number we're going to generate. So how this is going to work is we're going to generate every note possible that actually sounds good, so that way we can collect accurate samples. So let's go ahead and do that. So first we need a unsigned 8-bit integer, because 8-bit will give you all the way up to, I believe, 255 as a value. So that's going to be plenty for us. We don't need that many notes. So we're going to have a note num variable, and that's going to be initialized to 0. So that's going to keep track of the note we're playing. Then we're going to have a duty cycle number in case we want to switch the duty cycles. I explained those in a video, which I will link down below, what the duty cycle is, but it gives us all sorts of timbres. And on the Game Boy Advance, we have 4 duty cycles. So kind of neat. So we want to be able to use all of those. Let's go ahead and initialize that. And then we have a timer counter, because I don't really want to have to play all these notes myself. I'm just going to have the Game Boy Advance cycle through it second by second. So we're going to do a timer here. So timer counter. Go ahead, set that to 0 as well. All of these are pretty much 0. And then our second counter. So we're going to count the seconds too and kind of refresh everything so that we don't take up that much RAM. All right, so we got all those basic variables. Actually, we have one more here. So if you go ahead and I'll show you where I'm getting this from. If we go to the code and then we go to Tonc lib and we go to include and we go to memdef, you can see all the defines here. All right, so what I'm doing here when I say SSQR duty 1_8, that's going to be the specific duty cycles. So that's where I get those defines from. They're all in the library. So that's why it's important that we have this include tonc.h. So I'm going to go ahead and make an array of these duty cycles that we can pick from. And we don't need to modify this array. So we'll go ahead and keep it const. And then duty cycle bank. And size 4, because we have 4 duty cycles. All right, go ahead and, whoops. So we go ahead and do SSQR duty 1_8, and then SSQR duty 1_4. And I encourage you guys to try writing all this out, even if you don't understand it. And lastly, 3/4. Alrighty, so that is all of our duty cycles. Don't forget the semicolon, I almost did. So that will be that for all of our variables here. That will keep track of some stuff. So here we can see in this file, this is where we actually play our note. There's some stuff I did here to create a chiptune sound, but we won't worry about that now. I'll cover it at the end if we have time. For now, let's scroll down to this main function. So this is run at the start of our program, the very start. So we just set up all these sound registers. Looks like I didn't really mess with anything, except I decided not to use an envelope for the sound. I just decided to do the volume. So we're gonna set it to the maximum volume, which is 12. And then this little pipe character you can use to do multiple things in a register, kind of put multiple values together. So if we wanna do 2 things, set 2 things in that register, that's how we're going to do that. So I also want the duty cycle to be 0 at first, but really it will just be, this is how we do that, is we select the duty cycle number of that array, which is currently 0, so it's going to be SSQR duty 18. So go ahead and duty cycle num. Make sure we have a semicolon right there. And I'm also not going to play this beginning sequence that plays at the beginning, so I'm going to go ahead and delete that. Okay, and so we need these, we need the left and the right. So everything else I'm not going to be using. Okay, so instead of just one instruction in that if statement, we're going to have a couple of them, right? So we need to do those brackets if you know your C. And so what we're going to use the left and the right pad for is we're going to use it to be able to select a specific duty cycle. So in order to do that, we need to first limit the array. So we want to make sure if our duty cycle number is greater than 0, if that number is greater than 0, we're going to subtract that number whenever we press the left button. That's going to bring us, so if you imagine, say we're at duty cycle 4 and we want to go back, that's going to bring us all the way back to the first duty cycle we can pick from, but then it should stop there, right? We shouldn't be setting an invalid value. So let's go ahead and we'll make sure we don't do that. So we're going to go duty cycle num and decrement it by 1. So that's going to happen each time we press the left. Then we're going to do reg sound1 control. That's what that stands for. And every time we set these registers, we have to be careful because if you just type in one value, it's gonna reset all of the other bits. So we want to always set the volume. Doesn't matter if we've already set it before. We want to just always set that. So I'm going to do SSQR IVOL 12 maximum volume. And again, we're just going to update that duty cycle bank. So you notice we subtracted from the duty cycle num. So once we put it back, once we set that register again, it's going to update the duty cycle to whatever it is. Okay, so we're going to use this similar logic, kind of the opposite thing, if you like to think of it that way, for this next one. So in our array, we can't go past 4, right? And really that would be 3 because this starts at 0, so 0, 1, 2, 3. So we really can't go past 3. So what we want to do is say if duty cycle num is less than 3, then we can increase it. But otherwise, if it is equal to 3, we don't want to be increasing that. So we'll just do nothing, right? And so that's how we kind of put this instruction to some bounds that it can work with for that array. So we're going to do duty cycle num plus equals 1. That's how we increment that. So you can imagine if we go back to our array, that's going to be going forward in the array. And once we hit this value right here, which is 3, we're not going to go any further. So we're going to have to use the left button to go back to the first one if we want to, or whatever one. And we can actually just copy this one, although you can write it out again if you want. And yeah, that's that. So now we need to set up that timer. So let's go ahead and go down to this if statement here. So we got to be careful. What's happening here is we have a loop that says while 1. So what this is going to do is it's going to run this loop all the time. So we want to run our timer inside of that. That's going to play the notes each second. So what is this line right here? This line is actually sort of important because if you look up the v blank, if we look up the v blank is basically the refresh rate of the Game Boy Advance. So that's when it draws all of the frames. And if we look that up, Game Boy Advance refresh rate, those of you graphics nerds out there, it's around 59.73 hertz. So basically 60 times a second. So what I want to do is I want to divide this up into 2 parts of a second. So I want 1 second to play the note, and I want the other part of the second to leave silence so I can tell which note is which when we chop up these samples. And this is also useful for if you're using, say, Logic Pro. I know Logic Pro just came up with a new sampler which allows you to take a big long audio file of notes, and it will look for silence in that file and trim it to each of the samples, which allow you to create a instrument out of that. So it's important that we have that little block of silence there. So that's why this V blank is so important, because it helps us come up with the timing that's going to help us develop this timer, so we can have one part of the note playing and then the other part silent each second. So we're going to do, first of all, we have I'm not sure, oh yep, we did have the timer variables up here. So we have first our second counter and then our timer counter. So first of all, if we ever reach, say, 100 seconds, which I don't think we will, but let's just say that happened, I want to reset that, because once that value reaches 255, then we're kind of running out of space there, a little bit of a overflow. So we want to make sure that that gets to 0, and there's really no reason for it to be greater than 100, I think. So we're going to do if second counter is equal to 100, then I'm going to set that value back to 0. Okay, and now we're going to do if our timer counter reaches 30. So first let's go ahead and we want to make sure we increment that. So what's going to happen here is, as I said, the refresh rate happens 60 times a second. So basically, since we have this, where is it? In this while one, since we have that V blank inner wait, this loop is going to run at the refresh rate, because that's what the V blank is. So this loop is going to run 60 times a second. So we want to basically increment this, and once it reaches 30, that's how we know half a second has passed. So that's why we do that. So first we want to make sure we add that instruction, which will increment the timer counter. That's kind of like your what do you call them, like semi-seconds. So that's how that's going to count that. And if we do, so if our timer reaches 30, then we know half a second has passed. So what we want to do then is we want to increment the second counter, which actually this should be half second counter, because really a second hasn't passed. But I guess I left it as that because originally I did a second, but then I discovered I couldn't tell which note was which when I tried to chop up the sample. So we'll just leave it at that. But if you want to do like half second counter, that's fine too. Just make sure you keep the name straight. And then we also want to set our timer counter to 0, because that means that we also want to refresh the counter for our seconds, because that means we've hit the mark. So we want to refresh that. So then we're going to do, if basically our second is an odd number, that means that we want to play the note, because we want to play it for the first part of the second, the first half of the second. So we're going to do second counter and then this percentage sign, which is the modulo, or I think that's what it is. Modulo. Yeah, so that's called, the modulo. And that basically gives the remainder of a division. So if you can't divide the number by 2, so if that remainder isn't equal to 0, then we want to run these instructions, which is, it's going to basically end up saying that that's the odd number. That's the first part of the half second. So we're going to do, first of all, we're going to reset the frequency, because that's what we should do before we play the note. So that's how we reset that. And then our sound register, our sound control, we're going to set that to volume 0. So really, actually, this is the second half of the second, because if you think about it, really, the first part of the second should be 0, since we're 0 indexing everything. So think of it this way. It's hard to do a demonstration. So think of it this way. So this is the first part of our second, and this right here is the second part. So by this time, by this mark right here, we've reached 0.5 seconds. Okay, so this is 0. Our second counter here, that's going to be 0. But once we reach 30, that means we've actually, my bad, I'm getting mixed up. So think of it this way. So once we've reached half a second, once we've reached this point, that's when our second counter is going to be 1. And 1 divided by 2, that has a remainder, right? So that's not even. So we get the remainder 1. So what's going to happen is it's going to run through this. It's going to have silence in the first part of our second. And then the second part, it is 0, because 2 divided by 2, you can do that. So in that part, we'll run this next part that we're going to write, this thingy right here. We're going to run all of that in the second part of our second. So it's important to just keep that straight. It's a little bit difficult, but this is how we're going to do it. So yeah, coding's a little bit tricky sometimes, but you learn something, and the more you do it, the better it is. So don't stress out if you don't understand it at this moment, because it's really not the meat of the video. I think the other part, the other fun of it, is actually creating the instrument. So let's go ahead and continue on. Go ahead and put this second part in. So this is the second part of our half second, the part where we want to actually play the note. So if our second counter is an even number, which it means that if you divide it by 2, it's not going to have a remainder, then we're going to go ahead and play the note. So pretty much that same line we've been using, the famous line. Actually, okay, good. I thought that said duty cycle num. That would have given us an error. So I want to do duty cycle num for that. And then finally, we're gonna play the note, because that's gonna go up to here. If we remember our note play, and that's gonna do that. So basically, that's gonna allow us to sort of pick the note we want, which the computer is gonna do that. It's just gonna increment the note each time. So we do note play, and then note num, and octave. But if you remember, we have to include note 0, right? So after this whole loop, we want to increment the note, which I'll cover those instructions as well. So basically, in a scale, here's a little bit of music theory. Assuming equal temperament, we have 12 notes and we're starting at 0. That's going to mean our max note is 11. So that's really note 12 before we hit an octave. So what we want to do is say if our note reaches 11 in its octave, then we want to reset that note num to 0. And the thing about this is you'll see already in here we can change the octave through the left and the right buttons. So we don't need to worry about programming the octave because we can do that manually. It just saves us a bunch of time. So once that note num gets to 11, I want to reset it so it plays at the start again. So note num equals 0. But if it isn't 11, then we want to actually increment that note num so it goes up chromatically to the next note. And finally, we don't need this SOS. We can get rid of that because we're not going to be using that. If you watch my previous videos, you might understand, or just looking at this. I encourage you to try running this before, although I haven't really shown you how to build it yet, so never mind. Let's just go ahead and delete that. All right, so I think we've got everything in order. So I'm going to go ahead and save that. And now we need to get a program that's going to help us convert this sort of looking human language into Gameboy language so we can run it on the Game Boy. So what I'm going to do is go to the devkitpro getting started. So if you just go ahead and actually go to Google, devkitpro getting started, then click on that website and you can go ahead and download the graphical installer. Well, actually, I think I want the Mac. So we're going to go to the package installer. Then you're going to go ahead and download the PKG. And again, it's going to warn you, so you gotta go to the security and open it anyway. And by the way, I have a Windows and Linux tutorial for this, for how to set up devkitpro, if you want to check those out. There's a little bit better way I would do it now, but those will still be sufficient videos, I think, if you want to check those out, if you're on Windows or another operating system, Linux. I know there's a lot of Linux distributions out there. So normally once you run this, you want to go ahead and hit the reboot, but I'm not going to do that because I'm recording right now. And there's a specific reason for that, but we're going to kind of avoid that for today because I just don't want to deal with it. So once we have that installer set up, we can go ahead and go to a program called Terminal. This is a cool program because you can do a lot of stuff. What we're going to do is we're going to do sudo dkp pacman. So what sudo is, there's this thing on a computer known as the super user. So basically the super user, you can do anything you want. So what sudo is it's super user do. So each time we run sudo before a command, that's going to allow us to have, administrator permission or system permission for that matter. So we're going to do dkp pacman sudo dkp pacman s and then gba dev because we want to install the GBA toolkit. Then you enter your password, press enter again, and press enter again for all of these. Yes. All right, and it's installing everything for us. Now this may change, so there is a command you can use to check what packages there are. If it's unclear to you, you can just follow all the instructions on this website, which are pretty awesome. I'll have all of these linked down below so you can check those out. Alrighty, so it looks like once you see your name again, that means everything has installed. So what I'm going to go ahead and do is I'm going to go back to this code folder here, wherever it is. I'm going to go to that. I'm going to go to the Sound 1 demo, and on that folder, I'm going to right click, or whatever you call it, like secondary click, and then I'm going to open a new terminal at the folder. And if we do ls, we should see all the files in there. If we check this one, this is the one we just edited, right? So what I'm going to do is a couple of things here. The first thing you want to do is you want to go into this make file, and basically we need to tell this thing where the Tonc library is installed on our system, because remember, we're using those defines, the register defines, so we want to make sure it understands those. So we need to go to the finder, then go ahead, click go to folder, and then the root folder, so /. And here's a cool trick. If you didn't know this, you can hold down shift, then press command and dot. So shift, command, dot, all at the same time, and that will show all these hidden files that you didn't see before. And what I'm going to do is I'm going to go to opt devkitpro and then libtonc. See that right there? So instead of doing this, because that's not going to work, doesn't know where the heck that is, we're going to drag this libtonc right there. And that's going to fix everything for us. Okay, so now libtonc just turned into that. So when it sees libtonc, it's going to be fine. It's going to be all right. So we want to make sure we do that, because if you don't, you're going to get a bunch of errors. All right. Then we're going to run this command. So first we're going to set devkitpro. So we're going to say devkitpro equals, and that's going to be this. So drag that in, just like that. Oh, looks like we got to do that sudo. So whenever you see that permission denied, that's what you got to do. Interesting. Let's do another cool trick you can do is this one. Oh, okay. So that's already been set up for us. If it hasn't, you just go ahead and you would run that command, and then you would do export devkitpro. And whenever you see that $sign, that means you're referring to a variable within the terminal. So you want to make sure you do that. So yep, it's kind of mad at me because it's already set these up. So you want to make sure you want to check these. So echo devkitpro, make sure to use the $sign. Should print out something, okay? And then the echo devkitarm, that should print out something. So now what you're going to do is go ahead and do export path equals, and then you want to do devkitarm bin and then path. And what this is going to do is it's going to tell the compiler, it's going to tell terminal where our compiler is for the Game Boy Advance. And what we're using to compile stuff for the Game Boy Advance is the devkitarm compiler. So inside that bin, not that bin, inside this one, that's where all the compilers are we're going to be using. So you want to make sure that this thing is clear where those are located. So go ahead and run that, and we should be good to go. So now all we do is make. And it's making it. Oh, looks like we got a little error here. Just a little typo. So I'm going to go ahead and fix that. What line is that? 95. Here we go. All right, let's try it again. And there we go. You should see this ROM fixed. So that is that. We are good to go. I'm going to go ahead and close out of these. All right, so what you want to do now is open up your digital audio workstation of choice. And normally you would go ahead, go to preferences, and make sure that your output device, make sure your input is the Soundflower, then make sure your output is the multi-output device. And the cool thing about that is I can go ahead and go back to that code folder. Go to code. And then we go to Sound 1 demo. There should be a Gameboy. Laggy. All right, there should be a Sound 1 demo file. That's GBA. So we can load this up. Just go ahead and double click on it. Oops. I'm just going to go ahead and relaunch that. All right, let's try it again. Let's see. Is it going to let us now? Weird. Game Boy Advance. Oh, here we go. All right. So it looks like I just had to click on the Game Boy Advance one. So we double click on that. So you can hear I'm changing the duty cycles using the left and the right arrow keys, which would be the left and the right buttons on the Game Boy Advance. And then say we want to change the octave, you press either Q or E. So E goes up an octave, and then Q will go down. So using all of this, it can get a little bit annoying to listen to after a while, but using all of these, you just want to record those into your digital audio workstation. Alrighty, so after assuming you've recorded all of these samples and chopped them up so that each note is its own, if you want, I can make a video on that. Just let me know in the comments below, but I'm assuming you guys know how to do that. So you'll end up with something like this. So that's a very high note. And then say like a low note, like C2, which is what I started at. So you can see we have all of those notes and all of those ranges because we were able to generate them from the Game Boy. So what we want to do now is go ahead and open up Contact, which is what we're going to be using to work on the Maschine Studio. So I'm going to go ahead and open that up. And we want to create an instrument now. And the cool thing about Contact is you don't need to set up a third-party library really to use it. You can really create your own instruments. So that's what we're going to be doing. So I'm just going to name this Game Boy Advance init or something, something like that. And now we can go to the mapping editor, and we see right here that's actually C-2. So that's a little bit lower. But what we can do is we can just go ahead and drag, where is it? C2. You're going to drag that all the way to where, not C3, but where you see C2 right there. All right. And then once we press that, you hear how it triggers it. So basically we're going to be doing that for all of these notes. So I'm going to go ahead and fast forward this video so you guys don't have to sit here. Alrighty, so I've went ahead and put all the notes in there. So now we can go ahead and try playing it. Pretty cool. So if you want to save that, we can go ahead and do a save as. Yep, save edited instrument as. And I'm going to go ahead and save it with the samples. So go ahead, patch plus samples, save it to the desktop. All right, sweet. So now if we theoretically go to the desktop and open that up, we should have no problems. How to get everything working on the Maschine. So what you need to do, just leave the instrument wherever you saved it. So I saved mine on the desktop. So you want to leave that there. Then just go ahead, open up Maschine 2. And also have the Maschine Studio out if you want that. And then once you open up, it should be just like this. So you go ahead, click this button. Also, if your view isn't like this is the Ideas view. So just make sure you go to the Ideas view, click that Add button, go to Native Instruments, Contact. And once you're in there, you can just go ahead, load recent, Game Boy Advance init, then go ahead and close out of contact, and now it should just say contact. So now on my Maschine, I can actually see the instrument that I just created. So I'm going to go ahead and switch to camera view. All right, so now I'm on the Maschine Studio. So what I'm going to do is first, you'll notice that if we zoom into this here, you'll see that it says contact. That is completely normal. That's what it should say. Sometimes the other libraries will have the library name, but since it's a user preset, it's just going to have that contact. So what I did there is I held down this, let's get that to focus. I held down that shift and then pressed keyboard. That's going to bring it so we can play it as sort of a pad. So I'm going to unplug my headphones so you guys can hear this. So I'm getting new to the pad setup, but now just kind of making up some random stuff, but you can see we have our instrument now. And what's cool about this is we can go to you press the pad mode again, and it will show the chords, so you can do different chord sets like this one. So like pretty dramatic, I don't know what the word is for it, emotional. All music is emotional, but this one in particular I really like. So say I like it, I can use this feature called the note repeat, and I have it set to the 30-second notes right now. So this is going to arpeggiate that chord. And say I like that chord progression, well, I can turn it into music. And that's what I'm gonna show you guys right now. So I hope you enjoyed this video. I'm gonna leave you with this track I created, but I definitely hope you learned something. If you didn't like the video, make sure to leave a dislike and let me know why. But otherwise, if you did, make sure to leave a like and let me know what you guys wanna see in the future. I have a lot of ideas because people actually have been letting me know what they want to see, so lots of stuff. But anyway, I'll leave you guys with some peaceful music, and I'll see you next time. Peace.